In this video I'm going to show you how to do a Wilcoxon sign rank test in R and also how to produce an effect size for it. We only need one package for this tutorial, and that's the effect size package, which is going to produce us, surprisingly, our effect size, which is going to be a rank biserial correlation. So if you don't have this package installed, you'll need to do so. I'm just going to use this code here to create a data set that we'll be analysing. So if we just run that, it'll produce you a data set, and then let's have a look at our wide data. So this is what the data looks like, and it's in wide form because we have one participant per line and our data goes horizontal. So what I mean by that, we've got subject number 1, and here's their before score on a test and then an after score. And then we've got it for participant 2, before score, after score, so before and after some sort of intervention. And what we're interested in is whether there's a difference between the before scores and the after scores. To do the Wilcoxon test, we just need to use this function, which is from base R, wilcox.test. And this is really similar in the setup if you want to do a paired samples t-test. We need to tell R that we have a pair. So we have a pair of variables we want to compare. So in this case, it's the before scores from data wide and the after scores from data wide, and we just put a comma between them. Then we have tilde1, basically means we've got no groups, and we can add this exact equals false. You don't need this in, but just if you do, it gets rid of a warning message that often you'll get. However, it won't make any real difference to the results. So if we use that, so pair before and after, tilde1, exact equals false, here is our Wilcoxon sign rank test. And we can see our test statistic and our p-value here. Now if you read in some data and you attach it, you can actually write the code like that instead. If we use the attach function, we don't need to tell R what data set we're getting our variables from. We can just simply say before, after, tilde1, exact equals false. So it's the same code, we're just removing this bit of here where we're telling R what data set we're getting things from. So that will work if you've used that attach command and read in some data. To produce our effect size, we can use the effect size package. We can activate that from our library. And then we want a rank biserial correlation. So we use rank underscore biserial as the function. And then we can write exactly the same code as we did earlier. Pair, data wide before, comma, data wide after, tilde1. And that will produce us our rank biserial correlation coefficient, which is our measure of effect size. Again, if you've read in data and used attached, you could simplify that to say before, comma, after. Now sometimes we have data that's in long form, and this bit of code here will produce us our long form data. And long form, as you can see, it's a long data set. It's not wide because we've got subject before, and there's the score. So subject 1 before score, and then they appear again. Subject 1, here's their after score. So our subject appears twice, once under each condition. For things like t-tests and Wilcoxon sign rank test, R doesn't like long format. It usually likes long format, but in this case it doesn't. So what we can do is we can make the data wide essentially. So one way we can do this is basically create a couple of new vectors or a couple of new sort of columns that are just floating around in R, and I'm going to call them before scores. And what I do is say, from my data long data set, I want all the scores. Well, then this bit is critical. This bit says, I want these scores, but only if in this situation where data long condition, so when the values in the condition column equals, and it's double equals, mean exactly the same as before. So what this basically says is, I need a list of scores, which I'm going to call before scores, and they are going to be these. So when condition meets before, it's going to be those numbers only. And it's going to label them as before scores. And then we can do our after scores, which is exactly the same thing, except only if condition double equals after. So the after scores are just going to be the ones where condition is after. So if we run that, and if we could even look at these, there's our before scores. And they will match exactly the before scores. And there's our after scores. So we've got these two sets of scores. We can now compare them in exactly the same way we did before. Wilcox.test, pair, and then we just say before scores, after scores. So we're pulling in these variables that we've created here. tilde1 exact equals false. And there we go. We've got exactly the same results as before. And we can do the same thing with our rank biserial correlation. Pair, before scores, after scores, tilde1. There's our rank biserial correlation done. We don't need to say where these scores are sitting. We don't need, because they're not sitting within any form of data set. They're just sort of floating in ours. They're just some values that we've got here, before scores and after scores, and we just can compare them directly. So that's how we can do our Wilcoxon test, whether it's in wide form or long form data.